All right, so it looks like we've hit 2 o'clock, so we're going to go ahead and get started. Before we get going, just a couple of quick housekeeping rules. All the attendees are muted, so if you have questions, and we certainly hope that you will have questions, please put them in the room chat, and we'll get to those as they come up in some cases, or we may wait to the end depending on what the questions are. But we will be monitoring that. So. I want to introduce Steve Corey. Steve has been a great Mimaki partner for more than a year now. A equipment dealer, servicing dealer, and service bureau extraordinaire out of Toronto, Canada. So we invited Steve to come on and to tell us a little bit about his business, what he does with full color 3D printing, how he's been using the Mimaki printers, and show you some of the honestly just amazing stuff that Objects Unlimited has been turning out over the last year. So Steve, if you want to hit your presentation in the playlist, and we should be able to get rolling. There we go.
Great, thanks, Josh. Appreciate it, and good afternoon, everyone. Thanks for taking a bit of time to learn about full color 3D printing. As Josh mentioned, I'm with Objects Unlimited. We're a 3D printing value-added reseller in Toronto, Ontario. We sell 3D printers for Mimaki and other brands. We do a ton of different type of in-house production. We also do a lot of 3D scanning, which gives us access to some very unique geometry that we can certainly exploit with the Mimaki 3D printers. I have a great team and a lot of talented people that help us make some of the parts that I'm going to show you. So my goal for today is really to inspire you. I want to share some of the experiences that we've had with the Mimaki 3D printers. I'm going to talk a little bit about the product and the workflow that we go through, and really show you what's possible. This is kind of meant to be an information session, so a lot more pictures than words, and just to show you some of the stuff that we do. It's really a little bit of everything, and I wish I could show you the other 95% of things that we make that we can't share, but these printers have enabled us to do a lot of spectacular things. I've been doing color 3D printing for 10 years now. We have many color jet printers. I've printed tens of thousands of people and tens of thousands of other objects. And really, the Mimaki machines open the door for us to do so much more. Now, there's two types of Mimaki 3D printers on the market. I'm not counting the very large printer, but the 3D UJ553. This is a really stellar production grade machine. It's got a very large build chamber, 20 by 20 by 12 inches, and you can run this thing 24/7, 365. It is a production machine. The 3D UJ2207 has just been introduced. Now, this is a model maker. It doesn't quite have the throughput of the 553 or the build area, but my goodness, I have never seen a printer that can make products like this printer can make at the price point that it's at. There's literally nothing on the market that compares to the Mimaki 3D UJ2207 for model making. If you have a small shop and you are thinking of doing full color 3D printing, you should explore this option. They both use the same inkset. They're both capable of 10 million colors, and really the results speak for themselves. So I'm going to tell you.
Sorry, Steve, can you just mention real quick what you have in your shop of these machines?
I'm going to get there, actually, Josh.
Oh, sorry.
If that's okay. But yes, we certainly do. We do have two 3D UJ553s and a 3D UJ2207, and we just installed a 3D UJ2207 in Calgary as well. Our relationship with Mimaki kind of started in 2018 when we saw the head that everybody saw, that everybody was talking about, that everybody who's done full color 3D printing said, "Holy cow! How can we even do that?" So I was intrigued. I had to hang off a little bit because new printers are always a little bit of a challenge, and I didn't have an existing relationship with Mimaki. As we started talking more and more, and I saw some more samples, and I learned a little bit about Mimaki and what they do. It really seemed to be a strong fit with the area of expertise we have at Objects Unlimited, which is full color, organic shapes, high detail, challenging parts. really the material cost and the throughput of the machine, the amount of stuff we would be able to make at a cost-effective price for our customers, it really sealed the deal for us. But the big kicker was we needed to make a whole lot of little small people. We have a incredible partner called Little Canada. It's the best model railway set you've seen across 40,000 square feet, a truly unbelievable experience. If you're ever in Toronto, I recommend that you go. Part of what Little Canada offers is the littleization station. This is actually something that we developed at Objects Unlimited. It's our Cobra 3D scanning booth, and you can be 3D scanned, and then you can actually be made at 1/87 scale and become part of the Little Canada exhibit for the next 20 to 30 years. Pretty good volume of this kind of thing. COVID obviously put a little bit of a wrench into things, but we are making lots and lots of little people. On top of making recognizable sub-inch models of individuals, we made a few stock people too. Now, Little Canada, if you go there, very little is 3D printed. It's almost all done by hand. But during the end of COVID, to populate some of these buildings, like the Rogers Centre where the Toronto Blue Jays play, or the Air Canada Centre where the Raptors play, we had to make a lot of people. And the Mimaki 3D EJ553 just pumped out these models. We made actually over 16,000 one-inch models of people, all different skin tones and shirt colors and pant colors and hats and different poses, and it took like a week. It was really truly amazing what we were able to accomplish. And this is the kind of project where 3D printing can really help. Our Mimaki experience really has been pretty incredible. We installed the first 553 right before COVID. At that time, a lot of workshops were closed, a lot of stores were closed, people weren't going into the office, but people still needed parts. Now we've been in business for quite a long time, so we have a lot of contacts, and they started calling us and saying, you know, we need this, and the fact that we could print in really vivid color with a rigid material now, with super high quality, it just opened so many doors. Now, year one on our first Mimaki printer, we ran that machine for 5,600 hours. If you think about that, that's 3/4 of the year that machine was running, not cycling, but actually printing parts. I don't get that kind of utilization on many of my other machines, and the reliability was outstanding.
That's
As you
amazing.
can, yeah. So you know, one of the keys to having a well-run 3D printer is to have an outstanding operator. And Evelyn here doesn't have kids yet, but she has 3 kids. They're called Mimaki number 1, Mimaki number 2, and the baby Mimaki. And we see it time and time again with all the equipment that we sell. If someone really cares for these machines and really takes the ownership of them, you get significantly better performance. So we got so much work on the first machine that we really needed to install a second one. We just couldn't keep up with the demand that we were experiencing, and of course, redundancy is always good, and extra capacity is always good. So in January 2020, we installed the first machine. January 2021, we installed the second machine, and then January 2022, we installed the third one. I'm curious what's going to get installed here in January 2023, because it seems that there's a pattern. Yesterday, we went and we added up all of the runtime across the 3 Mimaki machines, and it's 15,450 hours. That's almost 2 full years of productive runtime on this equipment over the last 3 years. Really, I couldn't be more pleased. That's for sure. As a user, there's so many things that I like, and anybody that knows me or has listened to any of my talks before, I love color jet printing. I've been doing it for a really long time. We make many parts every day on color jet prints, but I can't do the things that I can do on the Mimaki. Adding tint, color, vibrant text that's really sharp, even at small pixel sizes. Reliability through long prints. Our record right now is about 155 hours of printing time on one part or one bed. The job you see on the screen right now is about 75 hours. And we don't worry about it. We don't worry about the printer running through the weekend. We don't worry about the printer running overnight or over 2 nights, because they really don't fail. And they just keep chugging, and we keep running. I can tell you that over the last weekend, we had a pretty big job to do, and we ran both printers 24 hours a day, 5 straight days, and they only stopped to get the parts taken off, the beds cleaned, and to run again, load a bit of material, so they weren't down for more than 15, 20 minutes, and just kept cracking through. And that's the one thing that I think is a real takeaway here, is the reliability of the
Mhm.
Mimaki machines. But also the material. The material's strong. It's pretty durable. The water soluble support is incredible, and we will talk about that. And there's not a lot of waste. If you look at some other polyjet style printers, or most printers that use liquids through a jetting head, they do generate quite a lot of waste, both when they're operating and when they're idling. This does not happen on the Mimaki. The waste tank is pretty small, and we empty it very rarely. That combined with the material cost really makes a lot of the parts that we look at producing viable. They really do. I would also definitely say the tech support from the Mimaki 3D technicians, both in Toronto and out of the Atlanta office, has been superb. We haven't had many issues, but when we have issues, as you do with large printers that you run all the time, these guys and girls are incredible to help us out.
So one question for you, Steve, is as you talk about these long print times and you talk about the reliability of the machine and things like that, how have you found maintenance on the machine? Are you finding that it's better, worse, in line with what you're seeing in other technologies like the powder machines?
There's really pretty little maintenance, to be honest. All you really need to do is clean the heads once in a while, clean out the scraper blade every 4 or 5 jobs, and load material. I mean, I'm speaking for Evelyn because she does it all, but it does not seem to be a major challenge. And even I can come in the middle of the weekend and after a very long print and turn over to another very long print with no fear of failure. And that is a huge peace of mind when you have a part that's running for that long, because they are not inexpensive in terms of material
Mm,
cost, and usually there's a pretty tight deadline.
sure.
Yeah. So lots of value in 3D printing. Really, 3D printing in full color. Really anything that's small and has some high variability. When I say small, under a foot, under 2 feet, more than that, the print time becomes pretty long and the price point gets pretty high. But models like we make for our friends at Biologic Models,
Mm,
really couldn't, I can't really see how I would have done this before. These beads here that I'm showing on the printer, there's like 2,000 some odd of these beads. This customer has a 3D printer. They print the beads and then they would hand paint them, and it would take 4 days. So we ran these prints overnight. It was about I think a 12-hour job, and a day of cleaning, and it saves them all the printing time plus 4 days. Truly value added there. We are, like, I think a lot of people these days, getting a lot of inquiries about NFT actualizations and bringing digital products to life, which we certainly are doing quite a bit of. Figurines and anatomical models, scale models. There's lots of different uses. We're starting to make some models that are used as mold positives for casting art pieces. We've made some functional tools and made some industrial parts because the material is pretty robust and the machine is quite accurate. I Again, I'm constantly amazed at the ideas that our customers have and that our people have, and the things that we can do on these machines. So I don't even know what the next killer application is. Collectibles today and model making today, but that will change, and it will be highly interesting to be a part of it. I can't wait, actually.
Yeah, I think that's, we've mentioned that before. I think you and I have talked about it, and I've mentioned it in other presentations. But I think it's really surprising or interesting to look back and see the vision I think that Mimaki had for this machine when it was first released. They were thinking, here are the markets that we expect it to be in, and we're in totally different markets, and they're so varied, like you said, from collectible tabletop items to medical models to you name it. And I agree. I think as the additive manufacturing industry starts to realize that color is something that they can use for more than just visualizing stress points and things like that. I think the industry is really opening up and starting to see the potential here. It's really exciting.
I couldn't agree with you more, Josh. And I've seen so much evolution in the technology over the years, but not just the technology, because there's a lot more to it than that. These are great tools, but there's there's more than just the printers,
Oh yeah.
which is actually a great segue. So I'm going to just talk a little bit about the workflow and how we go from concept to print. Really pretty straightforward, like every other type of 3D printer or manufacturing process. You design it, you process it, you make it, and then you finish it. Um, but there's some things to keep in mind. Digital design is super important. Okay, you cannot make a great part without a great design. People ask me to take a photograph and 3D print something, and it's really difficult to do that. You need that technical and artistic aspect, especially with this type of 3D printing. Um, Designing for additive manufacturing certainly is a plus, and when you understand the way that the printers build the parts, it can take away some limitations that you would have with traditional manufacturing. But there's also things you can do to speed up print time, to save material costs, to make a better part. I will say that I think the most limiting factor to the adaptation, especially of color additive manufacturing, is design.
Mhm.
Um, there are multitude more people available today that have outstanding design skills and training than there ever has been in the past. And this is what really, really excites me over the next 10 years, is when all this creativity is now going to be enabled by the tools that people are learning. And that's just going to create more and more incredible ideas. I put the picture of this ugly guy here in the middle just to illustrate, like, skin tone is really hard to do. Skin tone is pretty important. The picture doesn't really do it justice, but the skin tone is pretty good on this one. You can't paint skin tone, right? You can, but it's really complicated, and there is artistry and craftspersonship involved in what happens, and I think it's important to note.
Well,
Once you have a
one
3D,
one one quick comment just on the skin tone piece, because I think that is super important when people are looking at samples from 3D printers. Like if you go to a trade show, something like that, more often than not, a lot of our competitors, a lot of other companies are showing the brightest, most vibrant color that they can print. And to me, that's the easy part, right? I mean, if you have a printer that can only do 512 colors, you can still get bright, vibrant parts. It's those skin tones, the ability to have the subtle gradients to show slight shading, or to show that transition from one color to another. That's where those 10 million colors are super, super important. And I think that's a fantastic illustration of that.
I completely agree with you. Um, Once you've done your digital design, then we load the part into the 3D Link software. Super easy to use. Every printer has its own slicer. But it's interesting to look at the efficiencies that we get from multiple productions. So if I'm making one piece of a 4-inch high selfie, I'm just under 4 hours to make it. However, the printer is really efficient left to right. And so if I'm making 14 pieces, oriented a little bit differently so I can fit more in, the average print time per piece comes down to 35 minutes. Uh, if I load the bed on the XY, we can get average print time of 27 minutes. So that's for 56 of those 4-inch high selfies. So you think about, do a little bit of math, and what could you sell a 4-inch high selfie for? And what's your cost per piece and your print per piece? It's pretty attractive for this kind of thing. Um, and of course, it doesn't have to be all the same person, right? I mean, we run beds with dozens of different people or objects or things like that. There's a couple different modes in the 3D UJ553. There's a high quality mode. You can also do clear parts and embed geometries inside of other things. So lots of interesting techniques. Well, setting the print up takes really just a couple minutes, and the estimators are super accurate, which is helpful and handy when you're costing out parts. So what I like to tell people, really, and it's true, printing is the easy part. Once
Mm.
you have a beautiful design, you've loaded it and set it up to go, you hit go on the printer, and then you come back in 1 to 160 hours. And then you take your print off and off you go. This is kind of an example of the digital workflow. So this is a sculpture that one of our friends has been working on for a long time. We use some 3D scanning to digitally capture that sculpture, and then we were making a 3D print of a small scale version. That print there was, I believe, about 65 hours. And you can kind of see, and you will see as we go through here, how the supporting material works on this printer. It's not encasing the entire uh, cubic area, but it does encase the parts and supports to protect them. Um, for those people that do polyjet or other types of multi-jet printing, the support material cost on the Mimaki is really reasonable and cost effective for sure. So when we're finishing a print, we don't use anything fancy. At our office, we use some wooden picks, we use toothpicks, we use spoons and ultrasonic tanks with water in them. Small parts go into sieves, and that's it as far as tools. Our number one source of supply is the local dollar store, honestly, because we just don't need special tools for this. The support material melts off in water. It's a good idea to scrape off all the support material, or as much as you can, before you put it in the water bath, so that it just doesn't take so long. But you can throw parts directly into water. The number one key, though, in finishing a part properly is care and having the right type of skill set. The guy finishing parts there is just doing it kind of for a photo opportunity, but I shouldn't be finishing parts. I'm not good at it. I don't have the patience. I don't have the talent. Um, that is an important job that people often overlook. You can throw the parts in water and you can take them out and you can ship them, but they're not going to look as good as they're going to look with the right amount of effort and care.
Right, right.
Right. This is the person that should be finishing is the person that does it every day. So as you can see, we scrape off some of the supports where we can, and then we put it into ultrasonics. Sometimes for large parts, we use a bucket. We're not using any kind of special solvents or water. It's strictly tap water, nothing else. And after we remove the supports, the parts come out with their absolutely incredible level of detail. Now this part is white because it was asked to be white, but the same process applies with color, and you can leave the parts in water overnight and the color doesn't leach out and it doesn't disappear. Parts will fade a little, or will come out of the water a tad faded, but they come back in about 2 hours and look really amazing. The detail here, both from the scan and the digital modeling perspective and the actual talent of the sculptor is really spectacular, and this is the kind of stuff that we really enjoy doing. Doing a lot of these types of objects to make molds now, because the Mimaki material is pretty easy to cast against, and it's got a nice smooth surface. When you're finishing, there's lots of ways you can finish parts to add whatever effect that you want. You can clear coat, you can use lacquer, you can use paint. If you're trying to get something translucent or see-through, there's a fair bit of progressive sanding involved with different grits of sandpaper and some care. This is a large sign that we made that was bronze, so we printed it in two pieces on the 3D UJ553 because it's a pretty big part, and had it bronzed, and it looks amazing. This was done in 3 days. Just wasn't time to get it milled or to do it any other way.
And that, if I remember right, that piece is actually was displayed outdoors as well. Is that correct?
It was for 5 days. It was part of a large sculpture that we made with other methods of 3D printing. I didn't want to show, but yeah, it was stunning. Again, I'm pretty used to seeing excellent 3D prints, but this one with the bronze finish was really really amazing and really excellent. One of the great projects we got to work on was with the Royal Ontario Museum. They've been working on this exhibit called The Dawn of Life for the last 6 or 7 years. We've been speaking with them, but finally ready to do all the installation of stuff, of course, right when COVID hit. Again, if you're ever in Toronto, please go see this exhibit. It is some of the most amazing work that I've ever done. I still just can't get over the quality, the museum quality of 3D prints that we are able to put out. Now, this exhibit's going to be running for the next 30 years. My grandkids are going to go and see these parts that our team made at this museum. And once they've been professionally mounted and lit, these photos just do not do it justice. The paleontologists and the museum people, they love this because you can show the fossil, the actual fossil, and then the artistic visualization of this fossil 3D printed in full color, and it is truly awe-inspiring when you see this. These are some of the very earliest forms of life on Earth. We've tried to make these types of objects other ways, and really difficult to do. They were a cinch. This and Nectocaris on the right here is all one piece, and because the material is pretty forgiving, the antennas actually flex a little bit and they don't snap off. Same thing with the hallucigenia on the left side. Um, those spikes are all printed one piece, and we've printed that, as you'll see shortly, really, really small, just to see if we could, and shockingly, we can. Um, some more models that were made in a couple pieces because they're about a meter and a half high. We're able to do a lot of translucency and things where you can see the insides of some of these early forms of life using multiple shells and embedded colors, and then a fair bit of sanding. When you get into doing really complex models, that's where, again, workmanship and artistry come into play. Um, this guy here is one of the showpieces. 70 hours of printing, about a week of finishing, and uh, really incredible. The eyes are translucent and light flows through them. The all the tentacles and the teeth just came out with incredible detail. Um, Again, you can see how the support material works here. So these are the parts coming off the printer. We would break off some of the supports where we think that we can and allow the parts to survive, and then soak them in water after that, and we can get just tremendous detail. Then you can get even more challenging. So this kind of part was beyond our level of expertise, and this is where working with someone um, at a museum whose job it is to create exhibits really humbles you and makes you realize how much we rely on the technology. So we printed the body of this object, and we printed these feathers, which are paper thin. They might be 50 microns thick, if that, and they were all hand applied, sorted, hand applied, glued on with patience and skill. I think it probably took about a week, but what an amazing piece. Similarly with this guy here, you can actually see how the color is a little bit faded in the shot on the left because it had just come out of the water bath to remove the supports. Then all the other small features on the right were added, and they're made out of paper. They're made out of paper by hand and hand applied, and um, just stellar work. But they love it too, because doing this by hand and making all of the different legs and making the shapes and getting the colors is really time consuming and really difficult. So 3D printing has helped bring this exhibit to life quite quite amazingly well. I definitely hope some of you can get to Toronto and see those kind of things. One thing that enables us to make really great parts in the Mimaki machines is the true water soluble supports. If I had to spray these parts with a water jet to remove the supports, if I had to um, do anything other than soak them in water, there's no way on earth I could make parts of this size with this kind of detail. Again, I have dreamed that I could make parts like this molecule on the right, and I'm flabbergasted that this survives the printing process. And with this particular part, I've dropped it. I've dropped it a number of times, and it hasn't broken. For two reasons. One is the material has a little bit of flex and resiliency, but also the natural design of our genes and our, I don't even know exactly what this is, but the way that the bonds work actually adds strength to the file geometrically as well. I have dropped these small spiky models on the left-hand side just to see what would happen. Not the green guy, but all the other ones, and they survived. They did not break. We've also tested the material in a freezer. We've had cases of people freezing wedding cake toppers in the past, and just some parts don't survive so well in the freezer. But we froze a Mimaki part in ice, left it there for a few days, and then let it all melt off, and the part was fine. So lots of it just opens the doors to so many other neat kind of applications.
So Steve, while we're talking about the water soluble support, one of the questions that we've had in the chat is, does the rinsed material, the water, need to be disposed of in any particular way? Is it toxic?
I think it's always responsible to dispose of things. It's always good to dispose of things responsibly. So we use two ultrasonic tanks, a clean one and a dirty one. The parts sit in the dirty one, and then when they're mostly clean, they go into the clean tank. And then when the clean tank gets dirty, it becomes the clean one, etc. So we absolutely capture our waste and dispose of it properly as you should industrial waste. It gets pretty sludgy. I certainly wouldn't want to flush it down the sink in my facility because it will clog up your pipes. So it is standard water. We wear gloves when we're working with it, but it is non-toxic. There's no lead. And you have to practice proper materials management no matter what you do.
Yeah, I think from the Mimaki standpoint, we'd like to point out that the solid cured support material that can go right into the trash, no problem at all.
Correct.
The gray water, as Steve's saying, what's left over there, it really is dependent on your local jurisdiction, how they like to handle those things. Typically, we recommend that people would dispose of that similar to the same way that you would dispose of printing ink, that sort of thing. But you really just want to check with your local governance.
Correct. Thank you, Josh.
Hmm.
So just a little bit about the market, and didn't get a chance to put a pretty picture in here, but I mean, I'm seeing the color 3D printed market expanding rapidly. It's expanding rapidly because we have the technology, we have the design skills, and the asset bases are growing. And NFTs are an excellent example of that, where these are assets that are created, and now we can actualize them cost effectively and with a really high level of quality and repeatability. People are valuing those physical assets, and you see it in the collectibles space, as well as medical modeling, some other stuff. We're finding that short run production is viable. For parts that are 4 or 5 inches, the line's probably 200 pieces, where 3D printing actually makes sense compared to injection molding. And we can have comparable results, which is also super important, not just for prototyping, right? This can be end use products with mass customization continuing to happen as more tools are created and more designs are available. So if you're looking to get into this market, you got to find a niche, of course, that you can exploit. But anything that's small with high variability that needs high quality and you can get good money for is a great candidate for this kind of 3D printing. If you're experimenting and you're making a couple models for yourself, or you're trying different things, you're just getting started, the 2207 will make you gorgeous parts at a very reasonable price point. If you need to do production, talk to anybody that has a Mimaki 3D UJ553, and they will tell you that you can run those things 24/7, 365, as we have, and we've proven it, and you can pound out a heck of a lot of parts.
Yeah, one of the questions that was in the chat was when do the smaller machines versus the larger machine? How do you do it based off of part size, things like that? But I think you really answered the question here. The smaller 2207 really as a prototyping machine, as a testing machine makes a lot of sense. But once you're into any kind of volume, the 553 is really the way to go. I think Steve, you and I had a good conversation the other day talking about how the 2207, it's a smaller bed, it's a slower machine, but with the same resins and the same workflow, right? So it's not like it's a machine for the kids and then a machine for the grown-ups, right? It's the same workflow, it's the same quality that you're getting out of both machines. It's just really a matter of build area and throughput.
And I would say price point of the machine, I don't know if I could say it, but 40,000 US dollars for a full color 3D printer that can make unbelievable parts is pretty game changing. And there's really nothing else on the market within double that price point that can do this kind of part and can achieve this kind of quality. And especially with the fully water soluble supports and the workflow that we have, um, it it's a really interesting option for small shops that are starting to get their feet wet. And then, if you start to find that your volume exceeds your capacity, that's what the 553 is for.
Yeah, I think looking at the 2207, you have the ability to look at it from a scalability standpoint, right? You start with one. If you need a little more speed, you get two. You just doubled your speed for still less than $100,000. You add in redundancy, you add in the ability to do a little bit of load balancing, have one machine for production, have another machine for pulling in side jobs, things like that. Yeah, it's really an interesting product. We're excited to see where that goes.
It is true, and I think Josh made a great point there. You can have two of these machines for less than the cost of one of the competitive machines that doesn't really let you print a square and doesn't have 10 million colors. Redundancy is a nice thing to have, and extra capacity is a nice thing to have,
Yeah.
certainly. So I'm going to just reiterate again what I like about Mimaki printers. You can do anything. I'm going to play this quick little video here. It's not embedded, so just give me a second. But this is the kind of part that I'm that we make, and it blows me away that we can make this thing. Check it out.
Now, give an idea of the size of that model.
It's about the size of a baseball.
Okay.
Yeah, and I got to thank Biologic Models for letting us show that. That model's accurate. Those little green dots, I believe, are glucose. The red strands are RNA. The blue, I think, are different proteins. This is where it's such a beautiful intersection of art and design and utility and technology, and all these things just come together in this really awesome product. Definitely one of the best things I've ever been able to make or had the privilege of making, and we make them all the time because we can.
So one of the questions in the chat is asking about he's saying, and the posts don't break off like CJP. If you were going to try and print this same thing with a color jet or a powder based machine, a ProJet, what would the results be?
I don't think I'd try it. I mean, we've attempted things like this before. The posts are pretty thin and they have a pretty small contact surface to the model. I would say that if we might be able to do it, we might be able to make that in CJP, but what we would not have is the translucency where you can see inside the part, and I think a lot of the small details would get lost. The other thing is taking it out of the printer is one thing, shipping it is a different story, and these parts are pretty robust. Would it be possible? I think if we had a contest, maybe we could get it out of the CJP printer, but I'd be terrified to handle that all the time. These parts are much more robust. I hand this model to clients when they walk in the office and let them handle it, which I certainly wouldn't do with the CJP model.
Right.
And really, folks, that's the end of my presentation. I was trying to leave a bunch of time for questions, so I'm hoping that that I can help answer anything that you might have. This is pretty exciting technology. You can do some really neat things, and I must say, and it pains me to say this, but most of the really neat things we've done, I can't show you. We've made some products that would blow you away, and maybe someday we'll be able to share them, but not so much today.
So do you find that, I mean, you've been doing full color printing for quite a long time. Are you surprised that people are still not aware of the things that can be done with 3D printing, with color 3D printing? Do you find that people are still a little bit surprised by it?
Are people surprised by it? Oh my goodness, when people walk into our shop, if they aren't familiar with color 3D printing, they're blown away at the possibilities. The challenge is always having the digital file. So lots of great concepts, but then that requires the design and conceptualization to happen. We're seeing a lot of traditional design people, like sculptors, for example, moving into the digital world, which opens up a lot of possibilities. But yeah, people are amazed. We deal with a lot of advertising companies that just the ideas really start to flow, and that's when you have ideas and you have excellent digital artists and you have excellent equipment and you have excellent finishing. That's when you can make some magic happen.
Yeah. So we do have a couple of questions in the chat. The first one's this one's maybe a little awkward to answer, but what is the cost of consumables and how long do they last? So I think from the Mimaki standpoint, we would certainly love to talk to you and get you a quote, or Steve can also get you a quote on what the consumables. But I would say from a production standpoint, how do you find the cost of the materials versus other technologies or competitive technologies, let's say to color? And then as far as how long they last, I'm not sure on that question if that's more about shelf life or if that's more about how often are you going through stuff, which would relate more to volume.
Well, let me answer the second question first. So how long do they last? I mean, shelf life's a year or two on the materials. If you're asking how long the parts last, the first part I printed 2.5 years ago looks great. And I know there's parts that have been in the field for 5 years that are fine and retaining their color. And it's a durable, longer term material, or we never would have put it into a museum exhibit that's going to be there for 30 years. As far as the cost of materials, without telling you actual numbers, it's quite reasonable. Compared to color jet printing, your part cost is about the same as a solid part. It's pretty tough to hollow parts using jetting. Compared to other jetting technologies, I'm finding the material cost and material utilization 30% less, roughly, than some of the competitive technologies. It's pretty reasonable. Very much of it depends on your geometry of your parts. But the thing the Mimaki printers really have going for them, to me, is there's no waste. So when the machines are sitting, if it sits for a week, which ours don't, but if they do, your waste material for cycling through the heads to keep it moist is zero. As the machine is printing, your purging and your waste material is pretty damn close to zero. I think it took us maybe 7 months to hit a liter of waste on our first machine, and that was running it really hard out. And if you look at other machines and how much material you are dumping that you're not actually putting into the part, that has a big impact on per part cost also. There's no penalty for me to print one. So if I print one model and it takes me 3 hours, or I print 12 models and it takes me 3 hours and 12 minutes, there's no material cost difference from the 1 to the 12, because I'm not doing any flushing and I'm not making a verification strip. And that could be a pretty significant savings versus most of the other technologies that we deal with.
Excellent. There's another question, and again, I'm not exactly sure how to phrase this. Are you designing and doing most CAD, or are people coming to you with good geometry? So I guess
It's
that's more about, are you
yeah.
designing in house, or are you?
It depends on the client. So some people come to us with amazing geometry that's been done and vetted and tested and put together great. Some people come to us with a sketch on a napkin or a photograph. I'm blessed at my company with some incredibly talented digital designers that can actually make really complicated and really beautiful things from minimal direction. Um, and then we get somewhere in the middle where we get some files that maybe aren't quite up to the level of quality that we need to print properly. They may have gaps, they may have holes. So there is a little bit of file management, especially as a service bureau business, but it's really all over the place. It's a lot easier to deal with files that come in and open perfectly and go right to the printer. There's a lot less hassle on that, but we can add a lot of value to clients for doing the design for them, or for helping to optimize their design for long production runs or for durability or that sort of thing.
Sure. Another question that's popped up. How much more post processing do you guys do besides cleaning off the support? So without giving away any Objects Unlimited secrets for finishing, can you talk a little bit about polishing or coating that you might do?
Yeah, no secrets. Pretty much zero. We clear coat them sometimes. If we want to knock down the shininess, we'll hit it with a matte clear coat in the spray paint booth, just a thin coat. Um, that's about it. There are certain parts for certain uses where we do some sanding and some buffing. For example, eyeballs require a little bit of sanding and buffing to be done, but nothing fancy. Like there's specific parts, like ones that need to be bronzed or ones that need to be chromed, where there's some different type of post processing. But for most of the parts, it's clean off, soak them in water, and then let them dry and make sure they look great.
And then do you find that a lot of that, so let's say the spraying, or I mean the clear coat or the polishing, obviously bronzing is a little bit different, but for clear coat or for polishing, is that stuff that you're able to do 90% plus in-house, or you find that you're having to outsource much of that?
Oh, we do it 100% in-house. It's we buy spray paint from the local hardware store and good sandpaper, and then it really again comes down to talent and a finisher that really cares. If any of you know Jaime Martinez at Mimaki, that guy is the reason why their models look so good, and it's the same thing at our shop. Evelyn Thompson is the reason that our models look so good. There's the machine is a tool. The work is what makes the parts really sing.
Okay, another question. Are you using Magix or NetFab for file prep, or do you use the new Mimaki cloud-based tool?
I guess I don't use any of those tools because we have so many other tools with all the different printers that we have. There are certain softwares that we tend to prefer, but most stuff we just open in Mimaki 3D Link. If there's an issue, then we'll fix it in some other software. I don't really want to say which ones we prefer, but I don't use either one of those yet. I am considering using Mimaki's cloud prep tool because I think it's good to align your preparation with the hardware itself, but I don't know how I'm going to make my prints any better than they're coming off today through that. So we'll see.
They definitely look amazing. All right, I don't see any additional questions. So at this point, Steve, I wanted to thank you. You did not only an amazing job of giving us some insight to what you and the Objects Unlimited team do, but your slides were great. The pictures are fantastic. We want to let everybody know that this presentation was recorded, and we will be putting this all up on I believe there's going to be a YouTube section on the Mimaki USA YouTube channel where you'll be able to go back and review this. Certainly, if the Mimaki printing, full color printing, is something that you're interested in, and you're not at a point yet where you're ready to purchase a machine, Objects Unlimited is by far one of the most talented service bureaus around, and the stuff that you can see from the pictures, the stuff they send out is fantastic. Also, if you're in the anywhere in Canada and you're looking to buy a machine, Steve is also the right guy. Give him a shout. But again, thank you everybody. And if there's no other questions, I want to thank everyone for coming, especially on a Friday afternoon. This is the final presentation in the Innovation Days series from Mimaki, and it's been a lot of fun this week. So thank you, Steve. Thanks to everybody that came on, and we'll see you next time.
Thank you, Josh. Everybody have a great weekend.